Okay, these are your solving quadratic equations by taking the square root notes. And hopefully what you notice throughout this lesson is that it's very similar to when we solved the absolute value problems. The goal is to isolate the variable. But the problem is it can be confusing because if you take a look at the following two problems, the one on the left was completed correctly and the one on the right was done incorrectly. And so the question is, do you really understand why the student on the right tried to solve the way that she or he did? The example on the left is a linear equation. The biggest exponent is 1. And so we isolate the variable by adding 1 to the other side and then dividing both sides by 1/2. And the problem is if we compare it to example number 2 is actually a quadratic equation, because it has an exponent of 2. And so if you take the 1 and you move it to the other side, what happens is there's still a quadratic variable and a linear variable. And so this doesn't help us solve the problem. What the student tried to do was take a GCF out, they pulled the x out, and was left with 2x minus 1, and the problem is that it's not equal to 0 on the other side. And we learned last week that the only time you can factor in order to solve is if the equation is equal to 0 because of the zero product property. So the difference, or the main difference between the two problems is that example 1 is linear and can be solved by isolating the variable. Example 2 is quadratic and needs to be solved another way. So what is wrong with the second problem? The equation needs to be set equal to 0. Before we can use the zero product property. So for the past couple of days we've been studying different methods that we can use in order to solve a quadratic equation. We've talked about factoring, and we've also talked about using the quadratic formula. We've talked about how the quadratic formula will always work, but sometimes it's not the most efficient method because if you can factor, factoring will probably be quicker for you. But it's not always possible to factor. And so there is one other method that we can use, and this is what is related to the absolute value problems that we solved last chapter. And what we do is we call this method sometimes SADMEP, or solving by taking square roots. And what happens if you look at the problems down at the bottom, they are still quadratic equations, but all of these are missing the linear term. And because they only have a quadratic term and not a linear term, we can work backwards through PEMDAS in order to solve these. PEMDAS, or SADMAP, says that you should add or subtract to isolate the variable first. If we look at example number 1, there isn't any adding or subtracting. It then says we can multiply or divide, but example number 1 does not have that. Then we get to the exponent, and this is where we can take the square root of both sides. But what a lot of students forget is to put the plus or minus on their answer, because if I take 11 and substitute it back in and square it, I get 121. When I substitute negative 11 in and square it, I also get 121. If I do the same thing on number 2, I work backwards through PEMDAS, so I add or subtract first, but this problem doesn't have that. Then I multiply or divide. I'm going to divide by 3. I take care of the exponent by taking the square root of both sides, and I remember to put a plus or minus on my answer. When we're solving, we also want to go back and make sure that we put the answer in brackets. So on number 3, what I want to do is add or subtract first, so I'm going to add the 12 to move it over to the other side. I'm going to divide both sides by -1. The quick way to do that is switch both symbols. And to get rid of the exponent, I'm going to take the square root of both sides. Now 75 is not a perfect square, so I'm going to have to simplify it by separating it into 25 times 3. I use 25 and 3 because 25 is a perfect square. I can take the square root of 25 and get 5. The 3 stays underneath the square root, and I put a plus or minus in front of my answer. And finally write it in brackets. On number 4, I'm going to add 1 first. I'm going to multiply both sides by 25 to get rid of the denominator. And I'm going to take the square root of both sides. Again, 300 is not a perfect square, so I split it into 100 times 3. The square root of 100 is 10. 3 stays underneath the square root, and I put a plus or minus on my answer. Continuing on the back, these also are the same type of problems. Even though it looks like x is a linear variable right here, it does have the squared on it. We're not actually going to ask you to multiply everything together. Instead, we're going to try and isolate the variable by dividing both sides by 2 first. I'll get rid of the exponent by taking the square root of both sides. And as soon as you take the square root, you need to remember to put plus or minus on your answer. And this one had a set of parentheses, so the last step is to take the 3 and to add it to the other side. And 3 and 2 are actually like terms, so I'm going to add 3 and 2 together to get 5, and I'm going to subtract 2 from 3 to get 1. This one has 2 answers, and they're 2 different numbers, not just opposites of each other. So if we try that again, number 6, I divide by 5. Sorry, 27. I take the square root of both sides. 27 is not a perfect square, but I can separate it into 9 times 3. The square root of 9 is 3. I leave the square root of 3, and I make sure I write a plus or a minus. And I add the 7 over to the other side, but these are not like terms because the 3 has a square root of 3 after it, and the 7 does not. So my final answer is just 7 plus or minus 3 times the square root of 3. On number 7, I'm going to first add 45. And I'm going to divide by 2. I'll take the square root of both sides. I make sure I write plus or minus on my answer. I add 6 over to the other side. These are like terms, so 6 plus 7 is 13. 6 minus 7 is -1. Order does not matter, I just tend to write the smaller one first. On number 8, start by taking the square root of both sides. I can do that right away because the parenthesis is isolated with a squared. I make sure I write plus or minus on my answer. When I add 5 to the other side, those are like terms, so I can combine them. 5 plus 9 is 14. 5 minus 9 is -4. And when I divide by 2, I divide each of these by 2. So my answers are -2 and 7. On number 9, if I'm working backwards through SADMAP, I add the 10 over to the other side first. I multiply by 3 to get rid of the fraction. I take the square root of both sides. Make sure I write plus or minus in front of my answer. And I subtract 4 to move it over to the other side. These are like terms, so -4 plus 12 is 8. -4 minus 12 is -16. On number 10, I'm going to subtract 147. I'm going to divide by 3. And when I take the square root, this time something new happens. Yesterday we learned about complex numbers, and when we take the square root of a negative number, we end up with I. The square root of 49 is 7, and it also gets a plus or minus. When I subtract the 5 to move it over to the other side, I cannot add the 2 together. They're not like terms. The 7 has the I and the -5 does not. So my answer is -5 plus or minus 7i. Last two. On number 11, I'm going to add 13. And divide by 4. When I go to take the square root, not only am I taking the square root of a negative number, but it's also not a perfect square. So I'm going to separate it into -4 times +2. We just said that a square root of a negative number becomes an imaginary number. The square root of 4 is 2. And the other square root of 2 stays. I make sure I put a plus or minus in front of my answer. I subtract 6 to move it to the other side. And these are not like terms, so I leave it as -6 plus or minus 2i root 2. Last problem. Take 75 and subtract 103. When I take the square root, again, it's not a perfect square and it's a negative number. So I'm going to split it into -4 times 7. The square root of 4 is 2, and the negative becomes the imaginary part, times the square root of 7. Make sure you put a plus or minus. Add the 3 to move it over to the other side. Put your answer in brackets. Make sure you're very careful in your work. As soon as you take a square root, you need to put a plus or minus. The I is going to go in between the number and the square root if there is one of each of those. And make sure if they are like terms, you combine them, but if they're not like terms, you do not combine them. Shout out to Guillermo for doing his homework. Thank you. Hope this helped. Please complete the homework assignment that you also picked up in class and turn that in to me tomorrow. Thank you.